New topic. All right, so what we're going to do for these problems is in Algebra 1, what you've done is you've solved problems like 4x minus 5 is 3. That's been no problem for you. You add the 5, you get 4x is 8, and you get x is 2. That's algebra 1. If you've taken algebra 1, that's a relatively easy problem. However, we're adjusting this a little bit. I'm hoping that you can see that. I'm going to rewrite it in case you can't. This is 4 raised to the x minus 5 is 3. This is a completely different problem than that. Completely different technique. This is called an exponential equation, and the way in which you solve an exponential equation is completely, it's rather different from an algebraic linear equation. So let's just talk about some of the things we want you to do to be successful on solving a problem like this. All right, let's get a little practice. Generally speaking, what we're going to do is we're going to isolate the power of the exponent. We're going to isolate the power in the exponent, and then we're going to use this relationship. A to the y is x, can be rewritten as log base a if x is y. All right, so let's get a little practice. All right, I want you to practice with me, and if what I say to you is not clear, you call in. I want you to be able to see that this problem here is written in this form. This original problem is written in this form. So I'm going to need for you to tell me, for our problem, what's A? For our problem, what's A? I want you to be able to see that for our problem, A is 2. A is right here, and for our problem, A is 2. For our problem, what is Y? For our problem, what's Y? I want you to be able to see for our problem, Y is X. Same position. And for our problem, I'm going to ask you, what's X? For our problem, X is 6. All right? So if you can do that, you will be able to dominate exponential equations. All right? So that is the key. Let's do one more. Let's practice one more. All right? So again, this problem is written in this form. This problem is written in this form. All right? So for our problem, what's A? A is 3. See, you got A is a base here. 3 is for our problem, A is 3. All right? So now tell me for our problem, what's Y? Y for our problem, the exponent for our problem is X. All right? And then for our problem, what's X? X is 45. If you followed that, being able to solve this equation will be no problem. Just remember what I told you, isolate the power in the exponent first. Isolate the power in the exponent first. All right, let's jump into it. So to get 4 raised to the x minus 5 to look like this form, which was a to the y is x, can be rewritten as log base a of x is y. To get this equation to look like that, you got to add the 5 over. So let's add the 5 over. Add the 5 over. We get 4 raised to the x is equal to 8. All right? This is not an algebra 1 problem. You do not divide by 4 on both sides. And x is not 2. Don't just blind. This is not 4 times x is 8. All right, so now let's solve this. The only way to solve this is to use this relationship that we gave you. The only way to solve this exponential equation is to see that for our problem, A is 4. For our problem, Y is X. And for our problem, X is 8. All right, X is 8. So let's use this logarithmic relationship to solve this. So we have log base A. A is 4. Log base A. And we said that A is 4. Of X. X we said was 8. X we said was 8 is equal to Y. And Y we said was X. Now, That's the hardest part. Oh, I'm sorry. It's cut off. So that's the hardest part to setting up this logarithmic relationship. That's the hardest part to solving the problem. Now what we're going to do is put this in the calculator. The way you solve this is you take log of this number here, 8, over log of this base here, 4. I did not say take the log of the big number divided by the log of the small number. I did not say that. I just said take the log of this number here divided by the log of the exponent. All right, let's put that in the calculator. All right, let's put that in the calculator. All right, so we have log, the LOG button, of the 8. All right, and hit enter, and we divide that by the log of 4, and you get 1.5. 1.5 final answer. So you've just solved the equation. 4 raised to the 1.5 power minus 5. Next problem is 3. Let's isolate this exponent. Let's isolate that exponent. All right? So now what we have is this half is in the way. Actually, let's get this 2 out of the way. Let's subtract 2 on both sides. We end up with 1/2 times 8 raised to the 2x power is 7. All right, it's 7. We still got to isolate that exponent so that we can get this form right here. A to the y is x. So this 1/2 is in the way. Let's multiply both sides by 2 to get the half out of there. We get 8 to the 2x. Multiply both sides by 2, you get 14. All right? This is not an Algebra 1 problem. Do not divide 8 on both sides. That is very, very, very wrong. This is an Algebra 2 problem where the only way to solve this exponential equation, and when I say exponential equation, I mean the variable is in the exponent. The only way you're going to do it is to understand this relationship. So for our problem, A, I hope you see it, is 8. And for our problem, Y is 2x. And for our problem, X is 14. X is 14. Now, the only way you're going to solve this is to rewrite this as a logarithm. All right, so we have log base A, our A was 8, log base 8 of X. Our X, we acknowledge, was 14. Log base 8 of 14 is equal to Y. And Y, we said, was 2X. That's the hardest part. That's the hardest part. Turning your exponential relationship into a logarithmic one. Now you got to be able to evaluate that. The way you're going to evaluate that is log of 14 over the log of 8. That's equal to 2x. All right, so now you put that in the calculator. You put this in the calculator. So now you have log of 14. All right, so you got log of 14, and you divide that by the log of 8. And then you end up with 1.269 is equal to 2x. You still got to solve for x. You divide by 2 on both sides. And if you divide by 2, you end up with 0.635. X is equal to 0.635. Final answer. 0.635. Final answer. All right, so those are 2 problems where we're solving exponential equations. Solving exponential equations. All right, so now what I want to do is I want to get a little practice. This problem is very similar to these 2. Very similar. So what I want to do is I want to move on to some of these problems and see how we do. Now, these are called logarithmic equations. Hopefully, it makes sense on why they call them logarithmic equations, because you got the log in the equation. All right, and you're going to continue to use this relationship. A to the y is x can be rewritten as log base A of x is y. All right, you really, as you begin to get in Algebra 2, you really use this relationship quite frequently. All right, so now what we're going to do, if we were to do this problem right here, you'd want to isolate this exponent. you'd want to isolate that exponent. You would actually add 3/5 to both sides. But now, because we're working with a logarithmic equation, what we want you to do is isolate. We want you to isolate the logarithm now. We want you to isolate the log. All right, now the way you're going to do that is to get rid of that 4. So let's rewrite it in case you can't see it real well. Log base 3 of x is 28. You divide by 4. Divide by 4. You get log base 3 of x is equal to 7. All right, so now what you have is you have this right side. You have the form on this right side. All right, so what I want you to be able to see here is you can rewrite any log statement. You can rewrite any log statement as an exponent. All right, the way you're going to rewrite this log statement is a to the y power is x. I want to rewrite this as an exponent now. The only way to solve this logarithmic equation is to write it as an exponent. This problem is now in reverse to what we did before. Before we had an exponential equation, the only way to solve it was to write this as a logarithm. Now that we have a logarithmic equation, the only way to solve this is as an exponent. All right? And the more of these problems we do together, the more comfortable you'd be. All right, by the way, I'm going to post these problems on dominatemath.com. If you want to see this video, you want to study it, the way you study for a test or you study for math is you redo problems. So go to dominatemath.com, and what you can do is you can revisit these problems. You can pause it. You can stop. You can't pause what I'm doing now because I got to move. The show ends in 5 minutes. But when I put this on the website, dominatemath.com, you can pause it, you can replay it, and then you can study it, and that's when you'll see the effectiveness of studying. Let's continue. All right, so now let us solve this. So the way you're going to solve this is to rewrite it as an exponent. A to the y. What's our a? What's our a in our problem? Our a is 3. Our a is 3. All right, so a to the y power. What's our y in our problem? Our y is 7. Our y is 7. So 3 to the 7 is equal to x. What's our x in our problem? Our x is x there. All right, so that's how you solve a logarithmic equation. That's exactly how you solve a logarithmic equation. So you get x is equal to whatever 3 to the 7th power is. All right, so let's grab our calculator. So the way you raise to a power is you hit the 3, and then there's this caret button here. It's a caret button. That means raise to the 7th power. You hit enter, and you get x is 2,187. Final answer. Final answer. If you have a question, call in 312-738-1060. I have more problems, but the show works best if you call in. I got time for one more problem. That problem can either be what you recommend we do or what I have planned for us. All right, so last problem I think we're going to have time for. Let's take a look at this last problem. It's another logarithmic equation. The only way to solve a logarithmic equation is to transform it into an exponential equation. That's the only way to do it, or maybe a calculator or something like that. All right, so let's take a look. Let's take a look. Here we go. So we got this logarithmic equation. They could have written this problem as log of 2x is equal to 1.5. This is another way that you could have written this problem. All right? That's the only way you could have written this problem. All right? So the assumed base here is 10. All right? So let me finish this problem. We got a quick caller. So the only way to solve this, the base is 10. So we got a, which is 10, to the y, which is 1.5, is equal to 2x. So you get 10 to the 1.5. You put that in the calculator. Hang on the line, caller. We'll be with you in 1 second. 10 to the 1.5. You get 31.6 is equal to 2x. You divide by 2, and x is equal to 15.8. Sorry we had to rush through that.